Hello, this is Mr. Jarrett, and in this video tutorial, I am going to be taking you through how to assemble this caster wheel in SOLIDWORKS. So this demonstration is one of the introduction demonstrations or review demonstrations for TechDraw 2. If this demonstration really doesn't refresh enough for you, you are welcome to go back to the TechDraw 1 website. And in TechDraw 1, I have several different assemblies. Some of these might change depending on when you're actually looking at this, but I'm sure there are a few that actually have videos like this sawhorse, and you can review some of the things like using mirrors, using offset distance, using planes, how to mate different parts. So what we're actually going to be doing is just doing this caster wheel and hoping that you remember a lot of it. Some of you might just need to brush up on some extra things, but when you move on to whatever the next assignment is, in this case I have the backhoe next. When you move on to that, hopefully you will remember a lot of it. Anyways, so let's get started with the caster wheel. And if you're wondering why my screen looks slightly different, it is because I'm going to be using the remote desktop web client for SOLIDWORKS because I did not sign out a license. So as far as that goes, it says that you have the files. The files are provided for you. They're already in your folder. So you need to open up SOLIDWORKS, and you're going to start out by creating a new assembly file. Once you open a new assembly file, it's instantly going to ask you, what do you want to place in there, okay, or insert. So you actually have this window, this insert component window already open. Now, it's probably going to open to the last folder that you had up. So in my case, since I already did this as practice, I have the wheel demo already open. What you're going to need to do is find your Google Drive on your left side. And if you don't have your Google Drive, if you're on a computer where you're not going through the web client, you might need to download these files from your Google Drive. So in order to do that, you would simply go to drive.google.com, and you would find your TechDraw 2 folder, find wherever these files are, and just simply download. So for you, they will actually be in your TechDraw 2 folder, and you will have a folder in there called Assembly Files, and then you should have all of the files that you need. So this is the caster wheel. So if you are downloading them, that's going to be the same folder process that you're going to need to find in Google Drive, and you just download them. If you're using the web client like I am, or if your Google Drive is synced, maybe on a home computer or something, you have the folder right here. So I am going to place all of these in. In order to do so, I can simply highlight all of them, or you can click one, hold in Shift, and click the other one. However you want to do it, but you need all three of them selected, and you're going to hit Open. And if you remember back when we first learned this, it's going to now kind of go to an isometric view, and it's going to ask you to click and place it. So I'm just going to click and place. It should zoom out a little bit, and it'll ask you to place the other ones. So we just have three simple files. And as a review, whatever file you put in first, and it's normally alphabetical, or if you do one at a time, it's whatever one goes in first, that is going to have a little F next to it. That F means it is fixed, okay, fixed in place. So if I right click, you can see the only other option, which there's tons of just strange options here, but there's this random thing that says float. Float means that it can rotate or move around. So going all the way back to TechDraw 1, you learned in an assembly that all parts have 6 degrees of freedom. 3 translational, so left and right, up and down, forward and backwards, okay, and 3 rotational along the X, Y, and Z. So if they are not constrained, they will be under constrained, like this minus sign, then it has 6 degrees of freedom. You are trying to limit the degrees of freedom so that it is either fully defined or that it just rotates in the way that you still want it to. So in this case, this wheel is going to need to be able to rotate. Okay, so this thing is locked in place. That's perfectly fine. Okay, so I'm going to zoom in a little bit. And first off, I'm going to go up and get my mate tool. And here I am going to zoom in and I'm going to select the inside of this hole. So that cylinder. And I'm going to select that and the inside cylinder here, because what it will do is actually make them concentric. So it will line up the center of these two holes. Okay, it will line up the center of them, concentric. And I'll simply hit the green check. Now, if I hit Control 7 to go back to a nice isometric view, you can kind of move this around and play with it and see what way it's now constrained. We just added one constraint, so certain movements will be taken away. In this case, since we did like a cylindrical or concentric mate, this thing can actually move back and forth, but it no longer can go left or right. It can't go up or down, and it can't actually rotate because the center of these always have to be lined up. So it can rotate this way, but it can't rotate along the Y. Okay, so next is a little bit more complicated. What a lot of people would think to do is just do the inside flat part here and the inside flat part here. And I'm going to show you why we can't actually do that on this, why that's wrong. So you shouldn't do this, but you should just watch this part. So if I got the mate tool and I clicked that flat surface and rotated around and clicked this flat surface, look what actually happens. So I'll hit the green check and then I'll show you how to get out of this. So you see it's flat or flush here, but over here we have a gap, okay? But we don't want that gap. We actually want this wheel perfectly centered in between, all right? So first off, that's what we shouldn't do. Secondly, if you do a mate that you accidentally want to get back, I highly recommend not hitting the back button because sometimes that undoes a lot of things. So what I will show you is every single part over here that's listed, if you hit the drop down, like we just added that to the wheel, it has a folder that says mates in assembly. So you can actually individually see whatever mates were applied to that part. So in this case, the caster wheel. So that was the good one. This is the one that we don't want. Okay, so that is one simple way of deleting it. Another way that you can delete it is if you scroll all the way down, there's a folder that says mates. And that shows all the mates that have been attached or applied in an assembly. So you can delete it either place. Okay. And the more complicated way of getting this perfectly centered is actually using planes. Now, we could still create our own planes if we really wanted to, but what I like to do first is actually see if these parts have their own planes that go through the middle of them. So this caster wheel itself, if I just hit that drop down, I can move my mouse over this and I can see where the planes are. Okay, so we want a plane that's cutting through the middle from left to right. So it's actually the front plane right here. So you can see that's going right through the dead center of this. Okay, so let's see if the caster body has the same situation. So I just hit the drop down next to it. And the front plane there also has a plane going right through the middle. Well, that's perfect. So I don't have to make my own planes. So what I'll do is I'll hit the mate button. And notice I already had my caster body front plane selected, but say you didn't. Okay, what I'll do is I'll hit the drop down and I need to find my caster body, hit the drop down here, and I need to select the front plane. All right, and then I'll scroll down in this list. I'll find my caster wheel, hit that drop down, and I'll find the front plane there. So what I just did is I actually mated two planes. So I didn't even really click on a single flat surface. I'd use the imaginary planes that are cutting through the middle of it. So now when I hit the green check, you can actually see this thing is going to be perfectly spaced in between there. Okay, there's the perfect gap in between. So that's what we want. So next, let's look at this little pin that goes through it. So some of you are probably saying, okay, well, I already know what I need to do here. So let's do the cylindrical portion of it and the inside, just like we originally did. So that lined those two up. It made it concentric with the green check. And then if you notice with this head, a part of it is filed off or cut off. And there's this little part that comes down here. So that part, when it's all the way in, is going to keep it from rotating. So let's click on this flat surface, okay, of the caster body, rotate around, and we'll select the inside of the head here, so this flat surface. So now it makes those two perfectly even, okay, and if, say, for some reason yours flipped the wrong way, do you remember we have this mate alignment? Mate alignment flips the way it's aligned, okay? So we actually want it this way. This is the correct way. But I was just showing you just in case yours messed up or in future assemblies if it messes up. All right, so now we'll hit the green check. So this can actually still rotate, as you can see. So it can move only in this direction. It can't move in or out, can't move up or down. It can only rotate. So what we need to do now is actually select this flat part here, rotate around underneath, and select that flat part there of the caster body. And it's going to set them to parallel. So they're not actually touching, but they're parallel to one another. Meaning, we just told this little pin it can no longer spin. Okay, so if we look over here, you can actually see that the caster body is fixed. Caster pin, since we added 3 mates to it, is actually fully defined, and the caster wheel is underdefined. Now, we don't want to continue to make this fully defined because you still want that wheel to spin, just like so. Okay. Now, just to kind of see if you did everything correct, you can actually right-click on the caster body and hit float. And now everything says it's underdefined, even the pin. Even though you added 3, that pin is actually only defined to the caster body and the wheel. Okay, it's not defined in space. Meaning, when you move this, everything now moves together. Okay, so it is all one functional caster wheel. All right, so that is the demo. Again, if you need more help or more review, I would highly recommend going back to the TechDraw 1 website, or if I gave you a link there directly to the TechDraw 1 assemblies, I would recommend going back and maybe doing the Sawhorse because that's a quick and easy one with some video directions, or the planner box. I know the planner box is actually a very good one that has you not only make all of these parts very fast, shows you a very efficient way of doing it, but it also has you doing things like linear patterning, mirroring, um, doing a whole bunch of simple mates back and forth. Okay, so and that again is under 15 minutes. So that is a very, very good review one if you need something to review. But if you got the caster wheel and you're all good to go, move on to the next assignment. Good luck.